Welcome to the future of maintenance with AI-powered predictive maintenance. Our solution leverages advanced machine learning techniques such as decision trees, random forest, support vector machines, artificial neural networks, and Bayesian networks, along with statistical analysis to predict and prevent equipment failures before they happen. We collect and analyze data from the equipment, allowing us to schedule maintenance only when it's necessary, saving time and money. The system seamlessly integrates with existing infrastructure, providing an overview of available equipment health in real time. Experience the benefits of reduced downtime, increased operational efficiency, and extended equipment life. Join us in revolutionizing maintenance with AI-powered predictive maintenance. Today, we are diving into the world of AI-powered predictive maintenance. We will discuss the benefits such as reduced downtime and increased efficiency, and how data collection and analysis plays a crucial role. We will explore how it uses advanced techniques and technologies, including machine learning and statistical analysis, to predict and prevent equipment failures. We also cover maintenance scheduling and how our solution integrates with your existing systems. So let's get started on this journey to revolutionize maintenance. Predictive maintenance is a forward-thinking strategy leveraging data analysis to forecast equipment failures, enabling proactive maintenance. By harnessing techniques like machine learning and AI, it anticipates issues, minimizing downtime and optimizing efficiency. This approach enhances equipment reliability, cuts costs, and boosts productivity, making it indispensable in modern maintenance operations. In the realm of predictive maintenance, a fusion of cutting-edge technologies is at play. Machine learning and artificial intelligence, IoT, data analytics, condition monitoring, and prognostics all come together to create powerful tools. This amalgamation of technologies allows us to predict equipment failures, optimize maintenance operations, and ensure efficient utilization. It's not just about maintaining equipment, it's about harnessing technology to foresee, plan, and enhance. Predictive maintenance thrives on data. IoT devices and sensors monitor metrics like temperature, vibration, and power consumption. This data is analyzed in a central repository, enabling us to predict equipment failures. By scheduling maintenance at the right time, we reduce downtime, avoid unplanned maintenance, and increase reliability. If a machine is predicted to fail, maintenance is planned in advance, factoring the time for obtaining replacement parts, arranging personnel, and performing the maintenance. Continuous monitoring and updating predictive models ensure the effectiveness of our predictive maintenance efforts over time. Implementing predictive maintenance requires investment in hardware, software, and personnel. It's a complex process, but with proper planning, it can be integrated successfully. Key steps include understanding the program's goals and developing a cross-functional team. Implementing a data-driven approach, establishing a maintenance schedule, considering advanced technologies like machine learning and IoT, and continuously evaluating and refining the program to ensure its effectiveness. Predictive maintenance utilizes various machine learning algorithms. Decision trees and random forests use historical data to identify key factors leading to equipment failure. Support vector machines identify patterns associated with equipment failure. Artificial neural networks and regression analysis learn from historical sensor readings to predict equipment failure. Bayesian networks model probabilistic relationships between variables to predict equipment failure likely. The choice of algorithm depends on the problem and data characteristics. At the end of each unit, you will find several questions to test your knowledge. Here is one of the questions. What are similarities of predictive and preventive approaches? The answer lies within the materials covered in this unit.